I said, how many hours a week do you spend on video games? 90 hours a week playing video games. What kind of life do you have? So you want to be happy, they call it digital, the doctors have a disease now, it's called digital addiction. So please, no cell phones in class, no laptops, we're all going to live in the moment, right? Live in the moment and be happy. If you're unhappy, you're spending too much time with your technology. She's on your computer now, laptop. Look at her. I'm just asking.
My mom back.
That's not right, though. There's no cell phones in class. Nothing's that important. My wife had a birthday, so I said, I'm going to splurge for your birthday. I took her out to a restaurant. It cost $200. It was really nice. So this family was next to us, right? Mother and father, 2 teenagers, a boy and a girl, like 12 and 14. We were there for 2 hours. You go to a nice restaurant, you think it's a special occasion. That entire family for 2 hours, all 4 of them were on their cell phones the entire time. Nobody was talking to one another. They weren't living in the moment. Why do you go to a restaurant, right? You could go to McDonald's and eat a Big Mac or a Happy Meal and be on your cell phone. This was a fancy restaurant. You know, tablecloths and linen and wine, and cost me $200 for my wife's birthday. And there are couples there and their family, and they're on their cell phone for 2 hours. Guys, you gotta live in the moment. He's on his cell phone now. Look, we're talking cell phones, he's on his cell phone. What were you saying? Yeah, distraction. So if you're unhappy, the worst thing you can do an hour before you go to sleep is be on your cell phone. It keeps you awake. It changes all your, everything. People sleep with their phones, but it's not good for you. You don't get a good sleep.
What if I'm not happy because I'm not good at math?
You study. Yeah. Were you here the first class? Were you here for the first class?
I think so, yeah.
Remember I wrote down, I'm not good at math? Most people, when I do that survey, they write, I'm not good at math. You remember that. I want you to, whenever you say that, I want you to add this word. Yeah, can you do that? Say that for me.
I'm not good at math yet.
See that? The next 14 weeks, we're going to change that. You got to change your whole thing. Put your cell phone away. Instead of playing with that for 5 or 6 hours, open up my stat lab or open up the book, do those practice problems I gave you. We're going to change this whole dynamics. Hey, before I forget, was anybody not here last time? We did a diagnostic test. I need you to do this over the weekend if you weren't here. Everybody, we did it last class. It's just going to tell me what I need to concentrate on. Okay, anybody not get it? You need to use a number 2 pencil, okay? And you can't put an X or a check mark. You got to fill in the dot completely. Okay, anybody have any questions so far where we're at, what we're doing? So I gave everyone 2 worksheets with the answers on the back. Anybody not have these? These are everything we need to know for Module 10. If we can get across all of these, we're going to be experts, and you're all going to get 100 on the quiz and the homework, and we're all going to start Module 11 happily. So before I do that, though, let me show you something, guys. We're trying to develop a number sense. Do we have any science majors here? Anybody who's going to do biology, chemistry, or nursing? Nursing. I got a Christmas gift, a DNA test, where I had to spit in a tube, and they tell you your background. And I think it's really cool. So I just want to show you what they do, and I'm going to show you my results, because we're trying to develop a number sense so you can look at numbers and analyze them and really be comfortable, so you can be good at math. Yeah. So let me just show you this. How they do it. You spit in the tube and you mail it, and then they have computers, and they compare millions of pieces of data. They check out your DNA, and I have to see where this is though. I can't see here. I'm going to show you how they. I get 30, 40 emails a day, so bear with me, okay? Here it is. This is how they process it. If you're a science major or a nursing major, this is how they take your saliva and they figure out, they went back to 1600 and found my relatives from the year 1600. All these come in from all over the world. It's all done by computers and robots. They can tell me what diseases I'm going to be getting. So my wife and I got this as a Christmas present from our kids. So
Let's suppose that you're
they take this saliva and they compare it with millions of pieces of data from around the world, and they could have sent me like a 30-page report. One of the things we're going to learn later on is how to take something complicated and simplify it and use a graph, either a line graph, pie chart, some type of way to simplify stuff. So this is the one-page summary they sent me on my ancestry. I thought my grandparents came from Poland, and I was right. 100% from Europe, and they actually showed it visually here, Eastern Europe, like Poland and Czechoslovakia. I also had some French in there, and see if we can zoom in here. Also some French and German, Balkan area. So they take your saliva and they can tell you, and they went all the way back to the year 1680. And what they can do is connect you with your ancestry. So I might have a second cousin in South America somewhere, or a third cousin in Africa or anywhere. They give you a list of people that match your DNA. I mean, this is unbelievable that they can do this. And they can tell you, you have to fill out questionnaires and stuff, but they're going to use this for research to see how your DNA matches. Certain people are predisposed for cancer or liver disease or heart problems, and they're going to use that to analyze it. It's really some technology, but it's all using math and algorithms and computers and science and biology, looking at DNA. So it's stuff that 5 years ago they had no clue how to do it. Does anyone ever have it done yet? It used to cost $1,000. This was a $100 kit. It was on sale for Christmas for $50. I checked it out, see what my kids are spending on the year. But there was only $50 to get your DNA history. It's pretty cheap when you think about it. Have all that technology and find out what's going on. So I thought I'd just share that with you, because everything we learn is used in math and science. It's not that we learn it just for the sake of learning it. It's to solve real life problems. So here's what I wanted to do today. If I had to pick one area, and it was on this diagnostic test too, and it's an area that we need to learn, and some of you learned it before. But we want to take something complex, like DNA samples, whatever, and boil it down into simple numbers. So when we have an algebraic expression, an algebraic equation or expression is like a recipe. Anybody bake or cook here? Anybody cook? What you a baker?
Cook.
Cook?
Bake.
But you have a recipe to follow, right? Well,
For most things.
then other times you just do it, but algebra is just using recipes.
Mhm.
A formula, an equation, or an expression is just like a recipe. Like you want to make chocolate chip cookies, you buy a bag of the chocolate chips, and it says, we're going to get 26 cookies. You put the brown sugar in, you put the chocolate chips in, you mix it. And if you want 52 cookies, you double the batch. You want triple the batch? So we need to know, if you want to put a rocket up to the moon, it's a series of algebraic equations. You gotta look at the weight of the rocket ship, the weight of the astronauts, all the G-forces, everything else. They put all that together, they solve all these equations, and they're able to make a rocket go up and defy gravity. So I just want to go over quickly some of the rules where we look at terms, coefficients, how to combine like terms. We want to be able to write word statements as algebraic expressions, and then we have to be able to solve them. So a term is just quantities that we add together. Like if I have 4x squared plus, let me get a better marker, this one's not too good. This one here. Numbers can always be added to numbers. So when you combine like terms, the numbers can always go with numbers, but the x's can only go with x's, y's go with y's, but the exponent has to be the same too. So we want to take something complicated, simplify it. So a constant term is just a number. The coefficient is, this is the coefficient, this is the exponent, and that's the variable. So the number before it is called the coefficient, this is the variable, and that's the exponent. All of these slides are on MyLabs Plus. So anything I show, you can get into. If you're in MyLabs Plus, if you go to the video segment, see the PowerPoints here? The textbook and the videos and PowerPoints are there. So you can go to Module 10, all the PowerPoints are there for the whole course. So, in this example, this is a term, this is a term, this is a term, this is a term. So, 4 is the coefficient, 3 is the exponent. The number before it, this is the coefficient, 4x cubed. The fraction is a coefficient. Whenever you don't have anything in front of a variable, the 1 is implied. And when you have a number, that's the coefficient because it's a constant. These are just numbers and definitions that we need to know. But what we want to do is, whenever you simplify, you want to regroup them and combine the terms that are together. So here you've got a x squared and x squared, they can go together. The 12x and the 4x can go together. So you add these together. So this and that will give you the 3x squared minus 12 plus 4 will give you that. So you want to combine like terms whenever you simplify an algebraic expression. This is the one that most people, when you do a survey of algebra, people say they don't like fractions, they don't like word problems. But that's mostly what it is. We have to deal with negative numbers, we have to deal with words, take words and translate them into an algebraic expression and then solve it. And then, so we use variables. We can use x, a, b, y, any of that. So 3/4 of the square of a number, the way we would write that, I gave everyone the copy of this blue reference packet that you can use. It's got all the common words in it that for we only have 4 operations: addition, subtraction, multiplication, and division. So the secret is 3/4 is a fraction, 3/4. Of is multiplication. Square is x squared. So these words can be combined and written as 3/4 x squared. So I would really make sure you look at this. These are all the words we use for addition: sum, total, total of. This is subtraction. We use words like difference, decrease, minus, multiplication, product, multiply, division. We use words for exponents, and the equal sign is important. We use words like is the same as, is equal, results, amounts to, yields. And then inequality, we use less than and greater than. So the real secret is life is one big word problem. You gotta take everything you know, write the words out, then convert it to an algebraic equation. So, here's a problem I just want to show you. This is from the National Fire Protection Association. They have a real life problem. They're going to collect information. Now, no laptops in class, okay? No laptops or cell phones in class. So, if anybody stay focused. This is a real life situation. We have residential property fires in thousands. So they came up, they did a study, they may have collected like 1 million pieces of data. They all boiled it down to an equation. This is the algebraic equation. 111x squared minus 1,366x plus 6959. This is a constant. X is the number of years after 2000. So if you're in 2018, X would be 18. If you're in 2010, X would be 10. The number of vehicle fires in thousands is given by minus 52.5x plus 75. So this is an equation or a recipe that they developed, and they use this for insurance purposes. So what we want to do is find the difference between the number of residential property fires and car fires, vehicle fires. So we know the formula for house fires, and we know the formula for car fires. So what we can do is combine it. The x squared is alone. We have to combine the x with the x and the number with the number. This is a real life example of a problem. So what we do is we combine the 1366 minus the 52, and we get 1313, and then the 6959 plus 755 gives us 6184. So we've taken these two algebraic expressions and merged them, and we're doing the subtraction there, and we boil it down to this. So that's an example of how you would use algebra in real life situations. Yes, sir.
Why does it say a subtraction sign between?
Oh, well, they want to know the difference between the numbers. So they want to take the residential minus the vehicle files. The difference we know means subtraction. So the key word there is you want to find the difference. If they wanted to know what the total was, then it would be addition, you know. So there's only 4 operations: addition, subtraction, multiplication, and division that we're using. Let me do this, guys. I want to go through some practical examples with you again and see. But first of all, I have to, I made sure we had some late additions to our registry here. This is our 5th class already. Some people came in later. If I don't call your name, let me know. And some people dropped the course already. So Danielle's not here. Amanda Byrne, she's not here today. I'm getting to know your names and faces, so if you see me in the supermarket, say hello. What are you guys playing, dots and X's here? Come on, guys. This is college, not 5th grade. You guys are playing games with each other, dots and tic-tac-toe. I teach religion on Thursday to 5th graders, so if you guys want to switch classes, you can come with the 5th graders and play dots and Chris's with them. Karen Cox, not here today. Marco Esposito is there. There you go, Marco. I got your number now. You're the game player here. Xavier. There's Xavier. Eli Gonzalez, you feeling better? Okay. Flu is really bad, guys. Wash your hands a lot, and you need a lot of sleep. Yep. Melissa. Where's Melissa at today? She's not here? She's the one that called out for the car accident. Ezra, there you are. Abby's here. Brendan Hudak is here. Somebody had perfect attendance. That's a good thing. Friday is the biggest absenteeism day. People don't like to come on Friday, so give yourself a pat on the shoulder for coming today. Anne Marie, there's Anne Marie. You've been here for 5 classes. Good for you. 20 bonus points. We only have 43 more to go. It'll be May. It'll be May. You guys will be in your shorts, taking your finals. Joseph, Colleen? Joe? Not here today? Jasmine's not here today. Wow, a lot of people out. Joshua? Matthew Midler? Matthew? There you are, I'm sorry. Jonathan? There's Jonathan. Jonathan Nastory. How do you pronounce your last name?
Nastory.
Nastory.
Yes.
What nationality is that?
Middle Eastern.
Is it?
Yes.
Okay. Should get your DNA check, find out where exactly where it's from.
I'm good.
You're good? You pretty comfortable?
Yeah. I'm good.
Is Jenna? Jenna's here. Kiana's here. How about Wei Saba? Not here. No. Michael Smeltzer is here. Zay is here. How's the eye doing? Getting any better? Every day? Stephanie Taylor?
Right here.
Where's Stephanie? Ernesto. Ernesto's not here? No? Kirsten is here? Shane Walsh? Shane? Carly McCrone? You are? You all set? You all logged in and everything? Okay. Zach is here? Camise is here? Austin? Where's Austin? There you are. You're all logged in and stuff? Did you get the access yet?
I'm not sure.
Let's see, I don't think so. It's, guys, this is really important. You need to get in here and start doing some homework and quiz. So you're not in there yet, right? And, how about Taylor? Taylor Andres? You're here. Questions, sir?
Don't you have to pay to get the access to it?
Yeah, you get 14 days free trial if you want. And you can buy it online. It's cheaper if you buy it online. You have a credit card. If this is good for 3 courses, so if you had it for 020, you can use it for 022.
So I'm saying. The access code.
Okay, so we got attendance. Hey guys, I wanna really explain these to you. So we've been doing a bunch of problems together from these 2 worksheets. And the reason I do this is we learn by repetition and we learn by actual problems. So pick one of these sheets here. Who wants to pick the first problem? And I want to answer the question. Which one?
Alright, so it's on the chapter 3 of the board.
On which one? I have, 1A, okay, let me get that one. This one here, right? And it's on 3 and 4,
Yeah.
test form A, what number?
On the back is number
17. Okay, people don't like fractions, so 17, that's a pretty straightforward one because when you have the same denominator, you can just add the numerators on the top. So this is number 17. So the good thing is this, whenever you have the same denominator, you can just add or subtract it. So we want to take 3 plus a negative 5 plus 1. So 3 plus a negative 5 would give you a negative 2. Negative 2 plus 1 would give you a negative 1. So your final answer should come out to be, this is negative 2 over 13 plus 1. So this would give you negative 1 over 13. Now the answers are on the back. Sometimes you make a mistake or maybe the answer's wrong. So let's double check that. That's what the answer is in the back. So does that make sense to you? Okay? That's an easy one when you have the same. For the people that weren't here, I'm just going to do a quick summary. We're either going to add, subtract, multiply, or divide. The easiest one, I think, is multiplication. If you have like 1/3 times 4/7, you can just multiply the top. 1 times 4 is 4, 3 times 7 is 21. So multiplication is the easiest. Division, if you have 4/7 divided by 1/3, division is the opposite of multiplication. So what you can do is turn it into multiplication, and then you have to use the reciprocal. You have to flip the second one. So this becomes 12/7. I don't want to rush through this, but multiplication is the easiest. Just multiply the top and the bottom. When you have a division, change it to multiplication, then flip the second one, and then you can just multiply that.
If it's like a mixed number, mixed fraction, whatever it is.
Yeah, it's in, when the numerator is less than the denominator, that's called a proper fraction. In this case, this is bigger than that, that's called an improper fraction.
Yeah.
So what you want to do is, if you want to show it as a mixed number, you divide 7 into 12. That goes one time, and you have a remainder of 5. So that would be 1 5/7. Is that your question?
No, I was gonna ask if
Okay.
you're multiplying, like, whatever.
A mixed number.
Yeah, mixed number.
Turn it into a
You just turn it
fraction
into a
first.
proper fraction,
And then do the multiplication, it's easier, yeah. That's the only way you can do it. That's a good question. Yes, sir.
So you always have to have a least common denominator?
When you add or subtract,
Or a common, I didn't mean to
the
say.
same number on the bottom.
Yes.
Yeah. So, when you're doing addition and subtraction, if you have like 1/8 plus 2/8, you can just add those, right? But if you have 1/4 plus 1/2, you can't add those because the 3 and the 4 are different. So you have to convert them to the least common denominator, which is 12. So 1/4, you multiply the bottom by 3 and the top by 3. So 1/4 is the same as 3/12. And then 2/3, you multiply the bottom by 4 and the top by 4. So you get 8/12. So this becomes 11/12. So the best thing with addition and subtraction, when the denominator is the same, you can just add or subtract. But when they're different, you have to convert them to the smallest number that can be divided by both of them. And that smallest number is 12. It's called the least common multiple or least common denominator. So to take 1/4 into 12, whatever you do to the numerator, you have to do the same thing to the denominator. So to get from 4 to 12, you have to multiply by 3, but then you gotta do the top by 3. And 3/3 is just 1, so that shows you're not changing it. So 1/4 is the same as 3/12, 2/3 is the same as 8/12. Now I have the same number on the bottom, I can just add 8 plus 3 to get 11. But some people still don't get that, so please ask some questions, because this is like a building block. We're gonna be using it a lot. Fractions, you gotta make sure the denominator is the same.
Alright, what about number 20 on that page?
Okay.
Simplify the complex fraction. I've never seen that before.
Okay, well, let's do that then. A complex fraction is when you have 1/2, which is a mixed number, over 1/4. But this line here means divided by, so you can rewrite this as 1/4. Are you with me? So when this is a complex fraction, you have a mixed number and a fraction. So it means this divided by that. So another way of doing it is this. So we're going to convert this to a improper fraction. 2 times 1 is 2 plus 1. So that's the same as 3/2 divided by 1/4. But we just learned whenever you have 3/2, you can change it to a multiplication and you can flip the second number, right? So now 3 times 4 is 12/2. So my answer is 6. So it's this divided by that. Change this to an improper fraction, 3.5. And now we don't like to do division, so we change it to multiplication, then you gotta flip the second thing. Come here, no cell phones in class, come on. You got your phone, I thought your phone was broken.
It was.
You got it fixed.
Yeah.
And now you're gonna use it all the time.
No.
Come on.
It's just,
can't we, doesn't 2 go into 4?
That's a good thing, good question. You can simplify first and then multiply, or multiply and simplify. So that's a very good question. So what I did is, I multiplied and then simplified, but you could go 2 into 2 is 1, 2 into 4 is 2, 2 times 3 is 6. So I like to simplify first.
That's, I mean, for me, that's the first.
This
thing
is
I do.
easier, I think.
Yeah, that's what I do, so.
So 3 times 2 is 6.
No,
Whatever you do to any number on the top, if you do the same thing on the bottom, you're not gonna change it. So 2 into 2 is 1, 2 is there. I like doing this way, cause it's a lot easier to deal with smaller numbers. If you do this one, sometimes you have a real big number at top, so I think it's better to simplify first, then multiply. But you get the same answer if you multiply first and then simplify. Okay, someone else pick a problem out, guys. You learn by repetition, so we gotta be able to do all of these. Some of you guys have done the homework and the quiz already, and you're all done on MyLab Plus, and it's got high scores. So this is your competition, guys. You gotta get in there, and guys and gals, get in there and start working on these.
Number 58 on the
On that one, 58. Oh, this is graphing already, huh? Yeah. We haven't done any graphing yet, in detail, but I'll be glad to go through this with you, okay? We're gonna learn all about graphing. There's a whole chapter on it. So a lot of people, don't have the basic foundations for that. What number 58 you said, right? So I'll just give you a quick answer. If some people don't follow me, bear with me, because we're gonna spend 3 weeks on graphing. So, don't get too frustrated if,
I don't know that one.
Professor, what packet is that on?
that's on the final exam packet. It looks like
Module 1?
study guide, this one.
It's not on there.
Yeah, I think they got it.
Yeah.
Oh, is it?
Yeah, Isaac's
It's
trying.
kind of missing right.
Oh,
Yeah.
you know, maybe I had the wrong one here.
You just will do it.
I grabbed the wrong one,
Crazy.
sorry.
So,
Good catch, guys.
I was like, what the hell?
Okay,
is he talking
I had the
about?
wrong one.
It looked like it was.
We're gonna learn that though. It's 022. We're gonna learn how to do the graphing. That's why I was surprised it was on there. Sorry about that. This is about similar triangles, and we learned about ratios and proportions. Do you remember that? When you have a ratio, it means that one. I like to draw this because so. This is called a proportion. It means 2/3 equals 4/6. And what we did is, we learned that if you cross multiply for a true proportion, 3 times 4 equals 2 times 6. You get the same number on both sides. The number itself is a ratio. It says 2 is to 3 as 4 is to 6. So when you have similar triangles, that means they're proportional. What do we mean by proportional? It means that the scale is different. We have an architect here, he's not here, but this particular right triangle is proportional to that one, but it means one is bigger than the other. So what we want to do is find out the value of this x and this x. So the way you can do that is, because this is to scale, one is proportional to the other, so I can set up a ratio for this first one for 58. I'm going to say 5 is to 9, this side is proportional to this side, as x is to 41. So this one's a little bit bigger. This is 9, this is 5, this is 12. We don't know what this one is. But because they're similar triangles, one is proportional to the other. So does everybody see how I went there? I said 5 is to 9, this side is to that side, as x is to 41. Because this side's going to be proportional to that one, and that one's to that one. So now, by doing cross multiplying, I can solve for this, and I'm going to get 9x equals 5 times 41. So 9x equals 5, 205. Divide both sides by 9. X, so this is 2 9s are 18, and so 25 is 2, and 7 9s. What kind of answer did they get on this one? 58. Let's look at the answers. Doesn't seem right. 58, 13, and 40. Oh, they're not saying they're similar triangles. They're just saying, okay, this is another problem here. I thought there were similar triangles, but we're just using the, so we're going to learn about similar triangles and ratios again, but they didn't say that here. They're just saying solve it. So this is a right triangle. This is the Pythagorean theorem that you learned earlier. You take this side and square it, plus this side squared equals c squared. So in this case, this is 5, this is 12, and we want to find this. So we plug in 5 squared plus 12 squared is equal to c squared. So it's 25 plus 144 equals c squared. This is 169. Now I want to figure out what the value of c is. So I take the square root of c squared, the square root of 169. So the answer becomes 13. I thought they were similar because they had the two of them side by side, but they don't want that. Remember this Pythagorean theorem? A squared plus b squared equals c squared. So they give us the value of a and b, but we don't know what c is. That's what we're trying to find. So you plug it in, 5 squared, 12 squared, you get 169, but we want just c alone. So what we have to do is take the square root of that. But if you do it to one side, you have to do it to the other side. So you get 13 equals c.
So 169 divided by 2.
Yeah, the square root of 169 would be 13. Square root of 12 is 144. Square root of 144 is 12. And if you look on the back of your table that they gave you here, you can find 169 right here. And it tells you 13 times 13. This is really a good reference table when you're doing square roots. Right on the back here, it tells you. So let's do the other one then. We have 9. You always want to label it A, B, and C. So we know that a squared plus b squared equals c squared. So a squared is 9 squared plus b squared, we don't know what that is, equals 41 squared. So this is 81 plus b squared. Now what's 41 times 41? So that's 41, 4 ones are 4, 16. It's 1681. 1681. So b squared is equal to minus 81 minus 81, 1600. So the square root of b squared equals the square root of 1600. So b is equal to 40. So this side squared plus this side squared gives you that squared. So So we know A is equal to 9, we don't know what B is, and we know C is equal to 41. So 41 squared is 1681, 9 squared is 81, subtract it from both sides, you get B squared equals 1600. So you want to take the square root of both sides, so B is equal to 40. Everybody remember the Pythagorean theorem? That's on your sheet too. Who gives a sheet? No, that's a little joke there, huh? This is on the page here. This is called a leg, this is called a leg, that's called the hypotenuse. So it's a squared plus b squared equals c squared. So that was from module 6 in Math 020. So we're on module 10, which is just the review of modules 1 through 7 on 020. How are you doing, guys? Cheer up a little bit. I see some happy faces. Weekend's coming. Party time tonight. Who's gonna party tonight? Yay! In the dorms or no?
Yeah, I lived in the dorm for a long time. My brother and I are going to a party.
Oh. So no hangovers on Monday. No hangovers on Monday. Take your math lab with you.
What?
I used to have a girl that was a bartender over at Lehigh University in Bethlehem, and she used to, 2 o'clock in the morning, bartending with these engineers in Lehigh. She used to they used to help her with her homework over there. You never know where you're gonna find helpers, mentors. Okay, pick another one out. Somebody else pick one. You guys, come on. Eli, pick one out for us. Eli's the architect. He's gonna be using this on his major all the time.
Module 3E, I guess.
3. And what number?
It says letter E.
Oh, letter E? Whereabouts is it? Oh, this one, module 3, and it's E under number 26. 26E. 26E. So this is k over 5 minus 6 equals negative 9. Is that the one you want, Eli?
Yes.
So this is 26e. Now k is the variable, 5 minus 6 equals negative 9. So remember the strategy when we try to solve these guys. You want to get all the numbers on one side, all the letters, you want a positive 1k. So what do we do here? We would add 6 to this side. So you get k over 5, this goes to 0, and then this gives you a negative 3. Guys, this is really important because I need you to be able to do this. So the strategy is the equal sign. You want to get the k on one side, positive 1k, and you want to get all the numbers on the other side. So by adding 6 to this, I get rid of it, but then whatever you do to the left of the equal sign, you have to do to the right. So a minus 9 plus 6 gives you a negative 3. But I'm not done because this is k divided by 5. So the way we get rid of this is like 1/5. So if I would multiply it by 5, it would go away. So what I do is I take 5 over 1, multiply it, but then I have to do it to this side. So this cancels out and I get k, and my answer becomes negative 15. But we're not done. You always want to do a proof or a check. So let's take this. This is my answer, right? So you want to do a proof. So what you do is you take the k over 5 minus 6 equals negative 9. So you put the 15 in there, and then you would get, this would be 3. Why is that working? 26. Did I make a mistake here? Plus 6, that gives you negative 3. Oh, it's a minus here. So guys, this is what you have to be able to do for algebra. You gotta figure out the value of k that makes it a true statement. So, first thing you do is get the 6 to the other side, then you multiply by its reciprocal to get rid of it. So this will be k, but then you gotta do it to this side. And then you plug it back in, and if you get the same number on both sides, then it means that you got the right answer. Okay, Eli? Yeah? Yes, sir.
How about J?
J. Let's look at J. Oh, now you're kicking up a notch, huh? Testing my old man out here at the end of the day. See if he's still got the stuff here. I'm trying to improve my memory. I'm an old guy, 68. Did you hear there's a new natural herb? It's called ginkgo. You take these ginkgo pills, it improves your memory. So I went to the health food store. I got a big jar of ginkgo, but I keep forgetting to take them. So
Wait, what's it?
that's a problem, you know?
Yeah.
How do you spell that?
Ginko.
Ginkgo.
G-I.
Okay, so what we have to do is try to use a distributive property, get rid of the parentheses, get all the x's on one side, all the numbers on the other. So what we'll do is, distributive property is, we multiply the 15 times x, we got 15x, 15 times minus 2 gives us minus 30. And then we do the same thing here, 10x plus 10, negative 15. Now, here's the thing, guys. I would like to put a circle around these because these are all separate terms. Numbers can always go with numbers, letters go with letters. So what we want to do is combine these. So a plus 10 and a negative 15 would give us a negative 5. So let's do that first. Combine numbers. So we get 15x minus 30 equals 10x negative 5. Now, what I want to try to do is get the numbers on the right, the letters x on. I'm going to add 30 here, but then you have to add 30 here. So you get 15x equals 10x plus 25. So we're not done. We want to get the x's to the left, so subtract 10x, subtract 10x. You get 5x is equal to 25, but you want to solve for 1x, so you divide both sides by 5, so x is equal to 5. So this is really one that we need to be able, everyone needs to be able to do this. So you can't leave today till you know how to do this. We're staying till no parties. We're staying till 6 o'clock tonight till you know how to do this.
Well, probably don't start till 9.
9 o'clock, we're staying, if you don't get this, you can't leave. So we'll be here till midnight. I have no life, so I'm here. To me, it's like that one, huh?
Clowning.
Yeah.
Clowning.
Who doesn't get this? Please ask some questions. This is a key one. Now, you might think you're right, but remember we have to do a proof. So you should always double check it because maybe you made a mistake. So wherever the x is, you want to plug in 5, and then you should get the same number on both sides. Everybody agree with that? So let's do a proof.
Memory.
So I gotta take.
Exactly.
So wherever the
So
x is,
laughing.
plug in 5. So 5 minus 2 is 3. 5 plus 1 is 6. So we get 45 equals 60 minus 50. Look at that. Doesn't that make you happy when it works out? It's like an accomplishment. You did it. It's like solving a puzzle. Anybody ever try to solve a complex puzzle or something? Sometimes you don't get it the first time. And the thing with math is, there's only one answer. The answer is x is equal to 5. So it's really frustrating, but people have a fear of failure, and it's easy to make mistakes. Any basketball players here? Who's good? You guys are basketball players. So when you're shooting foul shots, you don't make every one, right? What's your percentage? You said it was low.
Yeah.
What is it, 6 out of 10 you make?
Yeah.
So those other 4, you don't beat yourself up for missing them, do you? You come back the next day and try again. So that's just the thing with math is, you gotta keep trying. What's your percentage on foul shooting?
Mine started with
5.5 out of 10.
Oh,
55%.
No, I'm more like in the game I'll miss like 2 free throws.
Yeah, but I need a percentage. How many out of 10 do you make? If you're gonna you're gonna go 8 out of 10, so you're a good free shot. So you're pretty good. So you're better than he is, but if he would practice, you could get 8. You believe him? He's making it up, huh? Yeah. So, yeah, okay. He doesn't believe you. He says he's 6 out of 10, you're saying you're 8 out of 10.
Yeah.
So we'll split the difference and we'll call you both 7.
Alright, that's fine.
Both 70% shooters. But math is that way. It's easy to get frustrated because, especially with MyLabs Plus, if they want 2 decimal places and the answer comes out to be 5.12, and say you get 5.11 or 5.13, no one's gonna die, things aren't gonna change, but because it's an algorithm, you gotta type it in and round to that number, so it's very frustrating. But, I mean, in the big picture, the answer's pretty close, right? It's not gonna change that much, but the trouble with math is it's very exact, and you need to, get that discipline to be able to do it, and don't get frustrated. You know, it's easy to make a sign error or a mistake. So how can we get over this math anxiety and being frustrated? Keep trying, right? Never give up. Quitters never win. Winners never quit. Sound like a coach here. This is my halftime speech. We're gonna go out there. This is our home. No one comes into our house and beats us. What are some of your halftime speeches you get? Your coach, does he use F word and stuff? They use the F word and stuff?
Oh, yeah.
Do they? The coaches?
Well,
They-
only like, cause we were actually pretty good. We only lost like 1 game, and like we were losing.
Did he ever throw any chairs against the wall or anything?
When he like a couple years ago, he did really calm down. Now he's older. Like he used to like break like cause our coach is like 6'8", 6'9".
He's a good basketball player?
Yeah, he played D1.
What high school?
Banger.
Bangor. Oh, so he's pretty good.
So he would break a lot of
What, you think that's effective?
It's scary.
Scary? So maybe that's what a math teacher has to do.
No.
Yeah, maybe I gotta start using the F word. Shut the front door. So, that front door I said now. Shut the front door. No one's leaving till we get this down. So, here's my job description, guy. I'm part-time, right? I worked 40 years in industry as engineer. But, here's my job description, right here. I have to teach, I have to instruct, encourage, mentor, praise, influence, guide, and inspire. So I'm a coach. I'm your math coach right here. So I'm gonna start picking chairs up and throwing them against the wall. I'm gonna make you guys go to the foul line. You have to keep shooting till you make 7 in a row. That's my new technique here. What do you think?
No.
No?
No.
You don't want that? Okay,
No.
well, I can do anything, so I'm easy. You want me to do it? Huh. No, seriously, guys, this is really, if I had to pick one problem, this is really everything we need to know from Module 10, how to solve equations, how to combine like terms, know the distributive property, how to handle negative numbers, then how to prove and check your answer. This is the whole enchilada right here. Who doesn't like Mexican food? I like Mexican food, right? Enchilada. Please ask, guys, this is really important. Please ask some questions. Are you okay with this one?
No, I need help.
Okay, which one? On this one?
No, yeah.
Okay. You know what, how about if we share it with everybody?
No.
We're not gonna embarrass you.
What do I do?
So, these are numbers. Numbers always go together. So, put a circle around it so you know it's a number. So 10 and negative 15 gives you a negative 5, right? Okay? Guys, I really recommend that you circle the terms, because sometimes the pluses and the minuses get lost and stuff. So this is a term, 15 is the coefficient, x is the variable. Numbers can always be added to numbers, add or subtract. So if you have $10 in the bank, and you write a check for 15, it means you're gonna be in a hole $5. So that's why we get the -5. But then, to get rid of a negative, if you add the opposite to it, it goes to 0, but then you have to add it here. So if you have $30 in the bank, you write a check for $5, you have $25 left. And then you wanna take the, x's, 15, and take away 10, gives you 5. And when 5 times something, you divide it by 5. Guys, I wanna give you a aha moment right now. Whenever we're working with math, we only have 4 different levers that we do: addition, subtraction, multiplication, and division. These two are opposites. So, and these two are opposites. So, like if I was gonna multiply by 2, it's the opposite of that is dividing by 2. And the same thing here, if I'm not going to add 5, the opposite is subtracting 5. So these two are always gonna counteract and be the opposite of each other, and these two are always gonna be the opposite. And in order to simplify, if you do the opposite operation, here, the opposite of a -30 is a +30. If I don't wanna multiply by 5, I divide by 5. So whenever you simplify, just do the opposite function to get rid of it. How are we doing? What are we gonna do this weekend? Gonna get into, do the homework and quiz for module 10? Bring any questions? We're gonna spend all next weekend on module 10, but, I need you to become experts in all of this. And you learn by repetition. You gotta go to that foul line and keep shooting its foul shots. So I'm not good at math yet. Don't remember that yet.
Yeah.
Don't forget it, yet. Questions, anyone? Okay, it's Friday, end of the week. You had enough of me. See you on Monday. Be safe. Guys, I need these diagnostic tests back on Monday, okay? I gotta get them in. Yeah, you can take the pencil, but bring it back, okay? I need these tests back on Monday. I have to hand them in or they're gonna fire me.
What do I have to go to again to get added on to the one?
I sent an email already.
Oh, you did?
Yeah, I think it's done already. Let me just see if you responded. She didn't reply yet, but I sent an email, asking them to,
add me?
yeah.
So just check manually if I can add
Yeah,
it, and then
yeah.
if not, I'll let you know on Monday.
Yep.
Thank you.
Here it is, look at here, yeah. I said,
Oh, so, okay.
these 2 people are gonna be at, she'll want to do it today or it'll be over the weekend. But you should be able to type in your student ID number.
So is it